the equation. One thing you should know, you should do هني is show button. You can select what to show, what not to show. مثلا in this physics you have the continua or continuum boundary conditions, and then the boundaries and the equation view. This is the equation view. It's a variable, and this is the solid equation view. Equation view. Wait. Shape function. Equation. Okay. This is the equation that's being solved. You notice the ones the terms we did: the source, the convective terms is the heat equation. Diffusive terms. This is the del dotted with the heat flux vector, اللي هو first derivative of temperature. So another derivative in E, and the I and J and K, they go away, and you end up with second derivative of temperature, and then these sources and the flux watt per meter cubed or surface like we did, or you have normal fluxes and etc. طبعا this is the constitutive equation اللي هو this variable is defined according to Fourier's law for conduction. If I say I don't want to see the equation view, this equation view هني will disappear. If I say equation view, it will give me everything: shape functions, variables, والأخوان. So I suggest you activate كل هذول: advanced physics option, advanced study options, advanced results option, even though you may not need them immediately. طبعا this will collapse everything, and this will expand everything, and this will display name with tag with type. This is the name, this is the tag, and this is the type. Geometry, and this is the tag, this is the name. So if I don't want the tag, we'll see this when we do this console using MATLAB, and this is kind of important. You only need الحين النame صراحة, just to make sure what is what. So definitions محتاجها وهذول محتاجهم. Geometry I'm done, والmaterial I'm done. It's expanded everything هذول. Yeah. What else, right? Oh, I mean heat flux, right? I need a boundary condition. طبعا في open boundary, في periodic conditions. If you have a domain that repeats itself indefinitely, you في boundary heat source. يعني heat source بس مو continuum هني، ولكن boundary heat source, like a line قاعد يطلع. أو in 2D it's a surface. Okay, so for example my interior thing, I cannot say this boundary. I can add this وتعطي heat right and left. If I choose this boundary heat source, it will give me my heat into the domain طبعا. Okay, makes sense. I don't need this. Actually, let me undo this. Don't rely heavily on the undo. Okay, it cannot undo that many steps. يعني don't get carried away. Undo, you cannot do. ما هونت ما بهذا, I can disable it, and it's like you deleted it. Okay, so this is disabled. In addition to duplicate or group والأشياء. When the temperatures, so if I have temperatures all together, هذول كلهم temperatures, I can say group these together. Okay, عندك temperature 100 surface, كل واحدة فيها duplicate 100 surface, and I can you know what, how to use this. I'll say ungroup الحين. Ungroup, وردهم مرة ثانية الفضل. So for the heat generation شنو لازم أسوي؟ It's not a boundary thing. شوفوا هذا line boundary. It's a domain. It's a continuum type of condition. Okay. It's not on a boundary of a system. It's a continuum. So it's either a solid, a fluid, or a heat source, or an initial value. These solids ones apply to the whole domain. Okay. So I could apply a thickness. طبعا هذا فيه thickness. 2D aluminum plate, 1 by 1 square feet. There is no thickness. Otherwise, so if there is no thickness, I could assume شنو؟ إنه 1. It's unit thickness. I don't care what happens. It's a unit thickness. راح يأثر. It won't matter much. If I assume it's infinite, يعني mathematically, numerically هني for my case, it doesn't matter if I say this is infinite, like a 300 mile, and I want a slice, a small slice, everything is the same. ولا it's a 1D, it's a 1 meter, ولا 1 inch, ولا 1 millimeter thick slice, but the end points are well insulated. المهم no flow into the page or out of the page. ولكن إذا في flux في أشياء تعتمد على thickness and the volume and the heat generation, whatever, so some things depend on these, you can assign a thickness. In my case, في thermal contact, boundary heat source. In my case, I need a heat source. A heat source applied هني. And again, 3 types of heat source, 3 ways I can add a heat source. A general watt per meter cubed this time, a line source, and a linear source, يعني with reduction absorption coefficient, and a heat rate watts, just pure. This much heat is being generated. What's my problem? It's 10 to the 5th kilowatt per meter cubed. So I can go to the general source and I can define this. Watt, 10 to the 5th. Yeah, 10 to the 5th. There are a million ways I can do this. I can see what the area is, and I can multiply by the area and give it a pure number. Watts, based on my area. I can also give it, or I can complicate this as much as I want. I can give it a function. A function named my function Q. Function 1. Well, my Q. My Q, it says unknown variables, but I can define a variable. A variable called my Q. And the expression is 1E5 وبس. This is my heat flux. Without giving it a unit. So when I say heat flux هني,
Doc, when you put an expression, can you put an equation as well?
yeah, of course, this is where I'm going.
Oh, okay.
So it gave me directly other parameters, variables, what, just a variable. If I say this is an inch, or inches, and I go to the heat source, it will complain. I expect watt per meter squared. This is a default unit. Initially, you gave me just 10 to the 5th. So I took something that's dimensionless and I applied my units in it. Like now, its reduced unit is meter. It's an SI. حول الانches إلى SI. But I'm expecting, watt per meter cubed. واضح? So I can put in a function, like you said. I'm gonna do this. No complaints. I can also define a function. What type of function? I could do a RAM, rectangular function or like a pulse. A piecewise function at this location حط لي هذا. This is especially useful in time problems. In transient problems, okay, the heat flux starts at 0 and at 1 minute it shoots up gradually, excuse me, until minute t equals 10 minutes, and then it falls down gradually at different rate. Or I could do a function, analytic function, or a MATLAB function, or a total external function, waveform, random, etc. Easy breezy, huh? So analytical function, I'll label it analytic 1. Yes, analytic 1. And the function name is an1. The function name is an1. So the expression is شو expression? What's the expression? يعني f of x, right? F of x. F of x is what? What do I do this? For my case, I want to use this function, an1. What do I write here? Expression. Yeah, no temperature. Heat flux. The argument, I have no argument. I have no argument in it because it's a constant function. I could leave it x, so I could do x, y, z, t, square, whatever. And this is a constant function. ولكن هني I have to say this, when I enter it, this an1 is a function of x. The argument, it takes an argument x and spits out a function. Function of x. It happens to be a constant function of x. How's it? So I could say a function of y مثلا وأقول إن الheat flux goes up with y. يعني the upper part of the patch generate more heat than the lower part of the patch. What if y goes to a negative? The x and y are the coordinates, عدل. What if y goes into the negative? في negative flux. Yeah. Y goes into the negative. Will this be defined? Answer me. Ladies? Must be.
I don't think so because they could. Oh. It depends on where it starts basically. You have the meter side here, it's 0, and then there's the meters on the left, right? It might not, I guess.
Outside the domain, it's defined here. So x will go from 0.01 to 0.02. Y will go from 0.01 to you could have whatever you want. X, Y defined in it. This function is defined in it. So this analytic function is fine. Argument,